In this application, we're going to go ahead and look at using the Acuity CL3 MG70 probe on a little stand. And as you can see, I've got a little glass slide that we're going to look at, a clear glass slide to go ahead and make it look very similar to measuring the position on top of a clear glass substrate. So let's go ahead and open up the CCS Manager. And as you can see, I've got it connected to the USB. It opens it up right away. And here you can see I've got it positioned where I'm measuring distance and intensity. So the distance is the top of the surface, but you have to be careful because in this distance mode, when you're on a clear surface, it does not necessarily measure the top surface, but it could measure partway into it. So what we need to do, the first thing I like to do is, I see I've got a good intensity, I've got a good distance. I would come in and look at the measurement, and I would change the configuration, and I would put it into thickness mode. The multiplex channel is 1. This is the probe size, the CL3, and we'll use the index of refraction of about 1.5. And you can see I've got it at 400 Hertz. So this looks good. I've got everything on USB because I'm connected to the USB, and no sense looking at the analog. You can scale the analog outputs if you'd like. So let's go back into the measurements, and you can see what I'm going to show you right now is we're going to go into distance 1, which is the top surface, and distance 2, which is the bottom surface. So as you can see here, we are seeing those two faces of the glass slide. So the difference between these two faces is the thickness. And as you can see, as I move it up and down, the thickness goes with it. So let's go ahead. So by that virtue, you can always tell where that top position is. So if you wanted to, you could make this a thickness, and it's approximately a millimeter. Yeah, this these Corning slides, they're approximately a millimeter. So you can see that we're very close. And so that 927 is that top distance. And you'll watch when I move this, you'll see how the position changes. Oops, let me put it back in the measuring range. But that thickness will always stay the same, right? So you can see that I'm moving the probe relation to the top surface, but that thickness will stay the same at about 1.049 millimeters. So a very accurate way to do it, and that's the way I would approach it. I would use your distance 1 as the top surface, and so with that top surface, you can go up on your target and be able to make those measurements. There are a couple other little configurations. There are preferences where you can invert the distance if you want. Convert to inches, you probably won't want to do that. You can add an offset. So let's change that, and you can see it changed the position of the target, but the thickness is the same. Something else really interesting, the configuration. If we know that this is we know that this is a millimeter. So if you knew exactly that was a millimeter, you could change your index of refraction to sort of dial it in a little closer. So let's just try. And this is one way that you could correct for it. And it's sort of little hunt and miss here. Let's try 145. So you can see that we're by adjusting that constant, you can change to a known thickness relatively easy if you'd like. Also possible to put an offset in. Just a real quick demonstration of the CCS Manager and how I would set it up to measure, to force the probe to measure on the top surface of the target.